Hello everyone, welcome back. This is the second video of my Zero build. In this video we deep dive into the radial engine of the A6M2 Zero, the Sakae 21. The previous video was the cockpit build of the Zero. If you are interested in watching it, please click the link on the screen or in the description below. As previously, I will build the 3D printed engine and the kit engine as well, so you can decide which one is better for you. The 3D printed accessories are pretty expensive, but the details and the quality are outstanding, much better than the already high quality kit parts. Alright, let's see what we have for this price tag. We have 25 3D printed resin parts and a PE sheet. The package contains not just the engine, but also the engine cowling. The packing is good, and I really like that the delicate parts are in a little plastic box to protect them. The instruction is typical Eduard, very informative and easy to understand. To start the build, the print supports must be removed from the engine. A good quality side cutter makes this process easy. One thing that I didn't like about the 3D printed engine is that it is printed in one block. I prefer if the parts are separated and I have to assemble the structure. It is simpler in this way for sure, but I like it better if I could paint the parts one by one and then glue them together. I had the same criticism for this cockpit as well. Basically the cockpit is printed in one block, but other than this, the details are outstanding and sharp. The kit engine is engineered differently. The two rows of cylinders are separate pieces. The back side of the cylinders is hollow, so I filled the gap with putty. After the putty dried, I primed both of the 3D and the kit blocks with black primer. According to the instructions and the pictures that I found on the internet, the engine block with the cylinders is black, but I wanted to make it a little bit more interesting, so I painted it dark metallic. I mixed super iron with a touch of black. My favorite metallic paints are the Mr. Color SM series paints because the metallic pigments are microscopic and super easy to paint. The push-pull rod pipes are black and the rings at the tip are silver. Though most of the time I don't like to use pure black, this time I used pure black because I needed high contrast. For the silver I used my favorite silver paint, the Mr. Color Silver C8. This silver paint is the best. To make another tone difference, I painted the intake manifold pipes titanium. Later I painted the front cover of the engine Tamiya medium sea gray. The kit engine is designed in a totally different way. All the main parts are separated. I like this way better because, for me, it's easier to paint the components. I used the same colors as I used for the 3D engine. The Nakajima Sakae was an air-cooled 14-cylinder double-row radial engine with a single-speed supercharger and a bore of 130 and a stroke of 150 mm. American experts who examined Sakae and Kansai engines in aircraft wreckage at Pearl Harbor described them as like a Swiss watch, comparing them with Allied aircraft engines. For the new fighter, the Zero, the main designer, Horikoshi, wanted to use a Mitsubishi engine. Mitsubishi at that time built two engines, the Kinsei 46 and the Suisei 13. The Kinsei was a 1070 horsepower, around 1200 mm diameter and 560 kilograms. The Suisei 13 was a little bit smaller in every aspect. It was around 1100 diameter, 875 horsepower and 526 kilograms. Horikoshi wanted to keep the airframe size down as much as possible, so the smaller 14-cylinder Suisei 13 engine was chosen. Excellent PE spark plug cables are included in the upgrade set, but I decided to make the ignition cables from LED wires instead. There's nothing wrong with the PE parts, it's absolutely usable, but it's too flat for me, so I made new cables from 0.2mm lead wire. I cut wires off from the ignition manifold ring and then glued the PE rings together. Finally, I glued the resin part of the ring on the top of the PE rings. For gluing, I used ordinary superglue. After it dried properly, I glued the 28 lead wires on the ring. The kit contains the ignition ring, so all I had to do was glue the 28 ignition cables on it. For this kind of job, I really like to use self-locking tweezers. There is no need to buy expensive ones, a cheap couple of dollars version is perfect. What's more, I always make them dirty, painted, so I don't really need a quality one. I painted the cables buff on the 3D version and desert yellow on the kit version. I don't really know what was the original color of the wires, probably silver. I wanted to use a color that pops out from the boring grayish background. Both of these colors worked well. Two prototypes were built and tested by the Navy Aviation Bureau. These two aircraft used the Mitsubishi Suisei engine with a two-blade propeller. During the first flight test, the Aviation Bureau sent an unaccepted request. They ordered the design team to replace the engine with the Nakajima Sakae 12 radial engine. Although the Sakae engine had more power, 950 horsepower, the designers weren't happy to change such a critical component of the aircraft, but they needed to obey the Navy. The third prototype flew on the 28th of December in 1939 with the Sakae engine, and it was a great success. The next step was glue the ignition cables in place. With fine tweezers, I shaped the lead wire, cut the excess with a fine scissor, and glued it with a touch of superglue. I like to use superglues which dries transparently. I shaped, cut and glued 56 cables in total. It was time-consuming but fun because all the wires were actually shaped differently. Obviously, during the shaping and gluing process, the paint on the wires was destroyed a little bit here and there, so I had to fix the paint job later. At this time, around 1940, Japanese engines were struggled with power rating at 1000 horsepower, while American engines were approaching the 1800 horsepower range. So the Sakae wasn't an extremely powerful engine. The twin-row radial-cooled engine was the result of a search for a greater engine power without an increasing in the frontal area. The concept of adding a second row of cylinders in a radial format would increase engine displacement for increased power without increasing the frontal area. According to the instruction, there is a pipe running at the front of the engine. I used 0.6mm lead wire for it. Unfortunately, this part where the wire is connecting is completely missing from the kit engine, so I made it from a bit of styrene and a piece of lead wire. It's an easy detail, but it looks good. On the top between every cylinder, there are tubes running. I made them from 0.3mm lead wire. Generally, I like to use lead wires for this kind of detail work. If I don't need structural strength, I prefer lead wires. We can buy them in different sizes from 0.2mm. To paint them, I used rubber black. As you can see, I use different tones of paint every time to create more variety. These rings are extremely fragile. During the cleaning I broke this front ring. Be careful with them, it was challenging to fix the broken one. The back ring was also painted in flat black. The 3D printed exhaust is very nice and detailed. For the base color I used burnt iron. To make it more interesting, I overpainted the corners of the pipe connections with a mixture of red-brown with a touch of rubber black. I glued the painted exhaust pipe with ordinary superglue. The fit was excellent, the parts clicked like Lego bricks. There is also a small silver air intake on the top of the engine. And basically that's it, the 3D engine is done. It was easy and quick to build. So after I finished the 3D engine, I continued with the kit engine. The kit engine's backside is completely missing. There are no air intake pipes or exhaust pipes. I started with the intake pipes. I used the 3D engine as a reference and I used 1mm lead wire to imitate these intake pipes. I shaped two different L shapes, 7 long for the front cylinder row and 7 short for the back cylinder row. Unfortunately, the long ones for the front cylinder row weren't long enough. It would have been better if I had cut them a little bit longer to make all the pipes more even. I realized this mistake in the end, and it would have been a massive headache to rebuild them, so I left them like this. But you can learn from my mistake and make the two rows more even. The next step was the main exhaust pipes. I used 2mm copper wire. I shaped it with a file and polished it with a sanding sponge. Then I bent the wires to the desired shape. I drilled the end of the pipes with my cheap mini drill. I like this cheap mini drill because it's small and more accessible to hold and use. Definitely not as powerful as its big brother, but most of the time we don't really need high torque. The shaped and drilled main exhaust pipes and the thin exhaust pipes from the cylinders were glued with superglue. After I glued all the pipes, I started to paint them. The intake pipes were painted titanium and the exhaust pipes were burnt iron. From Tamiya masking tape I cut little stripes to imitate the exhaust joints. For tone differences I used various brown colors and the end of the pipes was painted matte black to mimic the sole. Mitsubishi was the first in Japan to consider this line of engine configurations, follow the trend set by Pratt & Whitney at the United States. Nakajima's first attempt at double-row engines literally involved putting two single-row Kotobuki radial engines together. This move enhanced productivity since they already had the major parts in supply. Nakajima also made a number of changes to their first design. The crankshaft was redesigned in the middle with the roller bearing in the center for greater support between the two banks of cylinders. The main connection rod was of one piece, and push rods with cams were placed for and after the cylinder banks for better alignment of the intakes and exhaust valves. The redesign was a success and the improved version became the 850 horsepower engine. But the Navy insisted on 1000 horsepower from this two-row engine. Nakajima engineers started to build a completely new engine design. This final design is to become the Sakae engine we know. This new model consisted of better cooling fins, improved combustion chambers and better valve actions. Also noted was less vibration and more stable combustion pattern. The engine was placed in production in early 1939. There were two variants, the Sakae 11 and the Sakae 12, each having separate optimum operation altitudes. Operationally, the engine was known for its high compression ratio of 7.2 and particularly for its low fuel consumption ratio. This allowed the Zero to meet and exceed the specification requirements for long-range cruiser, which suppressed every Navy carrier-based fighter at the time. The two engines were done. It was time for some weathering. For weathering, I used oil paints. First, I washed the whole engine with highly diluted engine grease oil paint. My goal was highlight the edges, like the cooling fins on the cylinders. After the dark wash, I detailed it with various browns and greys. I really like to use oil for weathering. It is easy to mix and easy to apply on the surface. And because oil dries slowly, we don't have to rush. I left the oil dry for a couple of days. The next step was the cowling flaps. Eduard provides two options, open and closed position. For me, it wasn't a question. The open position is more interesting, and behind the open cowling flaps, the exhaust pipes are visible. With fine sanding sponges, I smoothened the surface and then applied a fine layer of primer. Unfortunately, the parts around the exhaust pipes didn't fit. I had to sand the exhaust and cut the flaps part into two pieces. I glued them with gel superglue. I had extra seconds to set the correct position before the glue set. After the glue dried, I fixed the paint and applied the rest of the parts. Again, I used gel superglue. This part was easy. All I had to do was set the parts one by one. In the kit, Eduard offers a super clever approach to assembling the engine cowling. There is a jig for the cowling parts. This jig makes the assembly so much easier. All I recommend is to use a bit of masking tape to hold the front part of the cowling on the jig. And then the parts just click together. I use Tamiya thin glue for gluing. Well done, Eduard, excellent engineering. I also drilled the exhaust pipes and I couldn't resist the urge to not modify and open the cowling flaps. For this surgery I used a saw blade. I cut the flaps in and then scratched them at the panel line. And after that, all I had to do is just bend them to the right angle. I recommend this modification if you make the exhaust pipes. Without the pipes, the cavity behind the cowling flaps looks empty. So these parts are working together. The last part of the 3D engine was the propeller axle. A final touch on the exhaust pipes, and I think the 3D printed engine is completely done. The early models suffered several problems like vibration problems and high cylinder head temperatures. These problems caused piston seizure and main connection rod bearing failures. Engineers made several changes and created the main variation of the Sakae engine, the Sakae 21. Eight bolts hold the two engine cowlings together. I found a good picture where these hold-down bolts are nicely visible. I imitate them with 0.2mm copper wire. There are PE parts for the covers, but they are too flat, so I bent them a bit. I used a round shape handle of a hobby blade. For the cover bolts, I used 0.1mm wires. Finally, I painted the cowling inside and outside Mr. Color C125 cowling color. This is a bluish black color. It looks pretty cool. The leading engineer of the Sakae 21 was Nakajima's designer Ryoichi Nakagawa. This Sakae 21 powered almost all of the Zero's variants like the Type 32, 22, 52 and 52A, B and C. The last in this series was the Sakae 31, which had water and methanol injection system. Okay, one more last thing. After I installed the 3D engine in the fuselage, I realized that the little air intake pipe on the top of the cylinders needed to be longer. There was a gap between the pipe and the fuselage cover. I cut a piece of brass tube to fill the gap and painted it metallic grey. Well, that's all about it. The kit engine is really good, and with a little bit of added details like ignition cables, we can make an excellent engine for our Zero. The 3D printed one is an entirely different level of details. I really enjoyed building both of them. Again, the definite winner is the 3D printed one. As I mentioned in the previous video, I plan to build a roof, and I will use this modified kit engine in that project. I hope you enjoyed this video and had a good time. The next episode will also be the Zero build, so stay tuned and hit the subscribe with the little bell if you haven't yet, and you won't miss the upcoming episodes. I hope you had a good time, keep modeling, and I see you in the next episode.